So the vertex that is the highest or lowest point on the parabola. We're going to talk about how to find the vertex algebraically, and you will have to find the x value first. To find the x value of that, let me write it off to the side so I can write it bigger, is going to be x equals negative b over 2a. We'll talk about where the b and a come from whenever we get to that example, but go ahead and have that there so that you can easily refer to it. The roots, the zeros, the solutions, the x-intercepts, it has four names for whatever reason. They all mean the same thing, and it is where the parabola crosses the x-axis. Most of the time you will have two, sometimes you will have one, sometimes you won't have any at all. In a couple lessons, we're going to talk about how to solve quadratic equations via factoring or quadratic formula. That is what you're actually solving for, is where the parabola is crossing the x-axis. Hopefully the y-intercept is pretty self-explanatory. That is where the parabola crosses the y-axis. And that is going to be the c value. Again, we'll talk about that, where we get the a, the b, the c value here in a little bit. The maximum, or a maximum parabola, is when the parabola has a definitive high point and you are going to have a maximum whenever it is concave down. Every time it's concave down, you will have a maximum. So a minimum is whenever the parabola has a definitive low point. And that is whenever it will be concave up. Concavity is whether or not the parabola opens up or down. The axis of symmetry is very similar to what it was in the absolute value unit, and by that I mean it is exactly the same. There's a little bit more on this one, so write a little bit smaller. It is a vertical line that passes through the vertex and splits the parabola in two. Now, whenever we did absolute value, the axis of symmetry was always, or how did I always write the axis of symmetry? X equals. And it was always x equals what? What number? The x value of the what? Of the vertex. Of those characteristics we talked about by looking at that graph. So looking at that, Ms. Blessing, what would the vertex be?
Isn't the highest like 9?
And what is the x value with that point?
4.
Awesome. And so if my vertex is 4, 9, Trevor, what is my axis of symmetry? X equals 4. Malachi, is this parabola concave up or concave down?
Down.
Because it is concave down, Trent, does it have a maximum or a minimum? Maximum. The domain is going to be convenient because if it is not a word problem that limits the domain in some way, maybe you're measuring something that can't be negative, but if it's just an equation, your domain is always going to be negative infinity to positive infinity. Now your range, if it is concave down, it's always going to start at negative infinity and go up to the y value of your vertex. Is it equal to that y value? Yes or no? Yes, so what needs to be on the 9? A bracket. Tanner, what's one of the roots on that graph? 8, 0. Michaela, what's the other one? And Austin, what is the y-intercept?
1.
Further down. 0. If it goes through the origin, 0, 0 is going to be one of your roots, and it's also going to be your y-intercept. Okay? So turn it over, go to the back of that page. We're going to look at an equation. We're going to talk about how to find all that information from an equation now, as opposed to a graph. So I'm going to refer to A term, the B term, the C term. That is all based off of the standard form. So ax squared plus bx plus c. Most of the ones we'll have today will be y equals. Equal to 0 is the same thing, especially whenever we factor, but for today, we're just going to have that y equals. So let's make sure that we're good on identifying those on this problem. Somebody tell me what the a value would be. Okay, so don't give me the x squared. What is the coefficient of x squared? Negative what? Negative 1. What is the b term? Or the b value? Negative 2. Okay, it's just the coefficients. A and b are just the coefficients of x squared and x. And c is just the last number at the end. So your formula for the x value of the vertex, which is also the axis of symmetry, so you're finding it here too, that is going to be that negative b over 2a. whenever I solve for that. Let's go ahead and solve for the x value. Casey, we said the b value was what?
-2.
And what was the a value? Okay. So I end up with negative times negative, which is positive 2. 2 times negative 1, which is negative 2. And so the x value of my vertex ends up being negative 1. To find the y value, I'm just going to take that and plug it back in. So I have negative 1 squared minus 2 times negative 1 for 2x minus 1. What does 1 squared equal? Negative 1 squared. Negative 1 times negative 1 is what? What, Trent? 1. Okay. But I still have that negative right there. So it's going to be negative 1. Negative 2 times negative 1 is positive 2. Then minus 1. And so what is the y value going to be? 0. Your y-intercept, that is going to be the c value of the equation. Which, Bree, what did we say the c value was? Okay. And, Brianna, what is the x value of all y-intercepts? 0. So make sure whenever you're writing in a y-intercept, you're putting 0 as that x value. Make sure you're filling in that information down at the bottom as we find it. Kate Sutter, what is the axis of symmetry? Okay, and so what would it be on this one? Just negative 1, or do I need to write something else with it? X equals negative 1. To determine the concavity, if the equation is positive, it is going to be concave up. And by equation, I mean that a value, so the very first term. If it is positive, it is going to be concave up, which means it will have a minimum. If it is negative, if it's negative, it will be concave down, which means it has a maximum. So the a value on this, is it positive or negative? Negative. Okay, so Holly, is it going to be concave up or concave down? Concave down. Which, Giselle, if it is concave down, that means it is going to be a maximum or a minimum? Maximum. Lisa Betta, the domain is always what? To write the range of one of these, if it is concave up, which means that a value is positive, you might have to write a little small here. It is going to go from the y value of your vertex up to infinity. If it is concave down, it is going to come from negative infinity up to the y value of your vertex. So Cole, what would the range be on this one? Negative infinity to 0. Alright, this next step is going to talk about how to find your vertex in the calculator. You can use your calculator to find it. Okay, so make sure that you're following along with me. Now, to put a fraction into the calculator, does anybody know how to do that? Alpha y equals. I'm going to have to do it differently up here because mine is not up to date like y'all's are. On the calculator, you have to be able to see the whole parabola, which some of you are already trying to follow the instructions. You're going ahead and going through the notes because it has the step-by-step what to do, but it doesn't talk about adjusting the window. So if you look at this, if you look at the parabola that's on there, hopefully you can tell that it's probably going to do something like this. So we have to change the window settings, and I need to extend my x-axis out, and I need to extend my y-axis down. It's almost, kind of think about zooming out on Google Maps. That's what you're doing. You're zooming out
How is your calculator up there?
so that you can see that. So what I need you to do, so to do that, everybody look up here. You're going to go to Window. That means everybody needs to be hitting Window. Marie Romano, hit Window.
I am hitting window.
Yeah. Okay, I'm going to extend my x max, change that to 20. Change your y minimum to negative 20. X max to 20. Y minimum to negative 20. Go back to your graph. You hit graph. And you should be able to see that parabola. Once I can see the vertex, it is clearly there. I'm going to hit second. Trace. Is that vertex a minimum or a maximum? It's a minimum, so I'm going to go down and select minimum. Whenever you hit enter, it is going to say left bound. You need to move your cursor by moving it left and right to the left of the vertex. Okay, it doesn't have to be all snuggled up right next to the vertex, anywhere on the left side of the vertex. So that right there is fine. You hit enter, then it is going to say right bound. You arrow over to the right, hit enter. These two arrows, if you look up here, these two arrows, and you'll see them on your calculator as well, it is setting a window, and it is going to tell me the lowest point within that little window. So if you hit maximum, it wouldn't give me that minimum point, which won't be the vertex. Whenever it says guess, don't guess, because if you hit enter again, it's just going to give you the point anyways. So you should get 8, negative 18. Now, raise your hand if you got something like I did on X, whether it's 7.999999 or 8.000001 or something. All right, guys, that's 8. Okay? For some reason, I don't know why, last class it gave me 8, negative 18 right on it. I don't know why it does it. I don't know the rhyme or reason, okay? But just, you kind of use common sense, and that's 8. The one that you're doing by the calculator. Make sure that you get negative 1/3, negative 5 1/3. Do not freak out and say, I got negative 0.33333. That is 1/3.
Can we keep it as a decimal or just...
I would rather it be a fraction on a repeating decimal, like that. Okay, so you're going to do the negative b over 2a. So you need to be able to identify the a, b, and c. If you are struggling with that, I would highly recommend that you just do that on top of every standard form you have. Just write A, B, C. Okay, it's convenient because if you know your alphabet, it's actually the first 3 letters of the alphabet in order. So it's very convenient. A, B, C is how the alphabet starts. So looking at this first, before we actually do the negative b over 2a, if that is negative, is it going to be concave up or concave down? Down. So is it a maximum or a minimum? Maximum. So now let's do the negative b over 2a. So I'm going to have negative b over 2a. My a is negative 4. Sorry, my b is 3. My a is negative 4. Okay. If I have a negative on that 3, it still stays there. It does not magically disappear. And so the x value of your vertex is 3/8. After you get that, you are going to plug that back in for x. Okay? So, looking at that equation, there's 2 x's. There's the x squared and the x. Which one do I plug it into? Both of them. Got it? In quadratics, if you're plugging a value in for x, it's every x that's in the equation. So I'm going to have 4 times 3/8 squared plus 3 times 3/8 plus 2. I want everyone to put that in your calculator and see what you get. It's not. Alright, I want you to raise your hand if you got 2.5625. Raise your hand. Okay? Raise your hand if you got 41 over 16. Okay. Does anybody know if you got this and you want a decimal, if you got a decimal and you want a fraction, how to do that? Don.
Go press math, and let's say it's a decimal, then first one's going to be fraction, and then if it's a fraction, then you can go down to number 2, it's a decimal.
So if you then follow them here. If you got this 2.5625 and you want it in fraction form, hit math, and one of those first 2 options is fraction. Hit enter on fraction, hit enter again, and it'll give you this. If you got this and you wanted a decimal, hit math, go to the decimal option, hit enter, enter, and it'll give you this. Okay. If you want to. So, let's go to the last page. So on these, we're going to do algebraically, so the negative b over 2a. So let's walk through this real quick. Again, it's nice because you can just do that. It's the negative parentheses, 2 parentheses. So, on this problem it says, when a ball is thrown, the height of the ball can be modeled by y equals negative 16t squared plus 80t plus 6, where t is the number of seconds the ball is in the air. What is the maximum height that the ball reaches? So, Elisabetta, what is the b value? What is the a value?
Negative 16.
Fabulous. That's going to give me negative 80 over negative 32, which is 2.5. There's the x value of your vertex. I want you to see if you can find the y value of your vertex. Okay, you should have gotten that. Listen up. That the y value is 106. So real quick, within this word problem, listen. Within this word problem, what does that point mean? explain. It is the vertex, but within the context of the problem.
It's the height of the bowl.
It's-
How high it goes.
Okay.
The height
What?
of the lowest point.
2.5 feet.
The 106.
106. What's the 2.5 representing?
The distance.
The seconds it took to reach that height. Make sure you know what the x and the y are measuring. Okay? So going down to 4. Kate Sutters, what is the b value on the second one? What is the a value? That's going to give you an x value of 15. I want you to find the y value. 875 on that. Alright, so let's look at this last problem. Please pay attention, because this problem is different than the last two. And you will see these in the future. So hint, hint here. Okay. These problems, you really have to have an idea as to all those different characteristics. The vertex, the axis of symmetry, what the axis of symmetry does. Sometimes the root, sometimes the y-intercept. You have to understand how all of those work in relation to each other. Okay? So on this it says, what point is symmetrical to the point 1,9 on the graph y equals x squared plus 4x plus 4? Anytime you see the word symmetrical, you're probably going to need to know what? The axis of symmetry. Okay? So to find the axis of symmetry, it's negative b over 2a. Okay? Because remember, axis of symmetry is the same as the x value of the vertex. Alright? Okay, what is the b value on this problem?
4.
What is the a value? Team Kate? 1. So I've got negative 4 over 2, which is negative 2. Okay? I will tell you, on these problems...
Or is that all you do?
No, you'll do more stuff on this one. Okay, so what we're going to end up having to do is you'll have a parabola. Okay, you'll have a point over here. You'll use the axis of symmetry to find the point that is symmetric to it. Okay, so to make sure that you are sketching just a rough draft of this. It is very hard to see this without actually drawing it. So on this, if I know that I have a point at 1,9 and I'm trying to find the point that is symmetric to it, do I have to know the y value of my vertex? I just need the axis of symmetry, which I know is at x equals negative 2. Now, is this one going to be concave up or concave down? Concave up. Why? Because it's a positive a value. That x squared is positive. So now, understanding what the axis of symmetry does, thinking about the x values, what is the distance from negative 2 to 1? 3. Make sure that you're paying attention on this next point. If that distance that I have up there is 3, is that distance 3 as well? Yes. Because it cuts it right down the middle. So what is the x value of this point then? Negative 5. If I'm at negative 2 and I go left 3 units, it is negative 5. Is my y value the same as this point? Yes. I didn't go up or down at all. I'm just going across the parabola. So that would be the point that is symmetric to that.